Hello, we are looking at logarithms today, and this is an example of a logarithm and what you might expect to see. Logarithms have a very special relationship with exponents. So logarithmic functions and exponential functions are tied together. Let's take a look and see what that is. So basically, a logarithm is the exponent value for a base to be taken to a set value. Okay, that sounds a little bit fuzzy though, so let's take a look at an example because I think that'll clear things up quite substantially. So more or less, here is up top the number 5 taken to the third power. The exponent is 3, and that equals 125. On the bottom, you've got a logarithm of base 5. That's the base, just like your base is up here in the exponent. That's the base of the logarithm. And basically it's saying 5 to some number, which in this case is the 3, what you've got on the right, is equal to 125. That's what the logarithm really gets at. It lets you fill in for the exponent because you know it's going to take you to some value here, though it's the 125, having that base 5. Let's look at some examples, and I think things clear up quite a bit as we go along. So here we go. I've got log base 4 is 256 of 256 is equal to x. Let's rewrite this. So 4, remember earlier I said that's the exponent, this thing right here on the right. So really what I've got here is 4 to the x equals 256. I can check and figure out what that is because I know 4 squared is equal to 16, 4 to the third is equal to 64, and 4 to the fourth is equal to 256. So if 4 to the fourth is equal to 256, therefore, since they both equal 256, 4 to the fourth is also equal to 4 to the x. If this is the case, then the exponents then must be equal. Therefore, x equals 4, and you've solved for the logarithm. That's all it is. That's all it is. Let's look at another. Okay, where do I begin? I have a base 2, therefore 2 to the x is equal to 64. Again, I start thinking 2 to the fourth, I know that is 16. 2 to the fifth is equal to 32. 2 to the sixth, there is our 64. So 2 to the x, since both equal 64, 2 to the x equals 2 to the sixth. Therefore, x equals 6. Now, when we get to something like this, let's plug in for x. We're going to solve this for x. Go back to what I've done already. Don't let this make things more complicated than it needs to be. Remember, my base is right here. So a to this power x is going to equal, well, I had 64 here, which I set to be what the base to the exponent was equal to. Therefore, I'm going to do the same thing here, except use a to the b. Now, if a to the x is equal to a to the b, there's only one way we can solve this, and that would be x equals b. That's it. Set the exponents equal to each other. That's it. Similarly, we can solve this the same way. Base is 6 to the x power is equal to 6 to the third. Therefore, x equals 3. With something like this, I think this is even simpler. There's your base, 4 to the third power is equal to x. What's 4 to the third power? 64 equals x. That's it. This is really just like finding the value of 4 to the third power, or whatever your base is to whatever power is over here. Okay? Review as needed, bring in your questions, and have a great day.